Hello students, welcome to the channel. Today in the Basics Explained series, we'll discuss linear transformations, that is transformations done to a line on the coordinate plane. So let's begin. We'll first look at horizontal transformation. So we have a line M here, whose equation can be easily found. We see that this line has a y-intercept at 0, 3. And its slope is going to be 3 divided by 1, 2, 3, 4, 5. So its slope is 3 by 5 and the y-intercept is 3. So the equation is y is equal to 3 by 5x plus 3, right? Now let's say we move this line 2 units to the right. 2 units to the right, meaning that this is how my new line would look, right? It was going through minus 5, 0, and then I've shifted it so that it now goes to minus 3, 0, right? So that's the shift that I'm making. So the new line is parallel to the original line. So the slope does not change, right? The slope remains 3 by 5. But what happens to the y-intercept? How do I find the equation of the new line? I need the slope and the y-intercept. So how do I find the new y-intercept? I can use the fact that the new line, let's say that this is line L, the new line passes through the point minus 3, 0 and has a slope of 3 by 5. Here M represents the slope. So I can use the slope point form to find the equation of line L. So for line L, the equation would be y minus 0 is 3 by 5 x plus 3. That's how we can find the equation. So that gives me y is 3 by 5x plus 9 by 5. So this is the equation of line L. Y is 3 by 5x plus 9 by 5. Now, could I have gotten this directly? Yes, I could have. If in the original equation of line M, for a shift of 2 units to the right, I had replaced x with x minus 2, I would have gotten the same equation that I've gotten here. So let's see how that happens. So y is 3 by 5. I'm replacing x with x minus 2. So y is 3 by 5x minus 6 by 5 plus 3. So y is 3 by 5x. And this, if you solve this, minus 6 by 5 plus 3, you will get plus 9 by 5, which is the same equation that we got here. So we get a rule for horizontal transformations. And what is that rule? That rule is if I move a line a units right, a units to the right, then I replace x with x minus a in the equation to get the equation of the new line. And if I move a line a units to the left, I replace x with x plus a in the equation to get the equation of the new line. For example, if in the same question, I had moved this line M to the left, if I had moved it 2 units to the left, then what was my original equation for M? It was 3 by 5x plus 3. This was for line M. And if I move it 2 units to the left and get a new line K, then the equation for line K would be y is 3 by 5 times x plus 2. I would replace x with x plus 2. So that would be y is 3 by 5x plus 6 by 5 plus 3, which is 3 by 5x plus 21 by 5, right? So this would be the equation of line K, the line that you get by moving line M 2 units to the left. Okay. Right, let's now look at the other kind of transformation, which is vertical. moving the line up or down. So here we have the same line again, whose equation we know is 3 by 5x plus 3. And this time I'm moving it 2 units up, which means from 0, 3, it will now go through 0, 5. The new line is going to pass through 0, 5. So let's say this is line P. So here I notice that I can actually get the equation of the new line pretty quickly because the new line has the same slope, right? The slope of P is the same as the slope of M, since they are both parallel. So that is 3 by 5. And since I moved it 2 units up, I know the y-intercept directly. The y-intercept is 5. So for the y-intercept for line P is 5. And so my equation is simply going to be 3 by 5x plus 5. This is the equation for line P. So here I did not have to do anything actually. I just increased the constant 3 in line M by 2 units to get the constant 5. Okay, so this is straightforward. So what is the rule for a vertical transformation? When a line y is equal to mx plus c is moved a units up, the equation of the new line is y is equal to mx plus c plus a. And when a line y is equal to mx plus c is moved a units down, the equation of the new line would be y is equal to mx plus c minus a. So if I were to move line M, which is y is equal to 3 by 5x plus 3, 2 units down to get line Q, then the equation of line Q would be 3 by 5x plus 1. I'll just subtract 2 from 3. So that's all, right? That's a pretty straightforward transformation. So let's try this sample question. The graphs of the linear functions f and g are shown in the xy plane above. Which of the following defines g in terms of f? So I have gx here, right? And I have fx here. And I notice that if I look at gx in terms of the vertical transformation of fx, then from 0, 2, I have moved down to 0, negative 2. Right? So let's say fx was whatever the slope is. Let's quickly find the slope. So the slope is 2, right? So fx is 2x plus 2. So if I have moved gx 4 units down, then gx will be 2x minus 2 because 2 minus 4. And you can see it's also true because indeed the y-intercept for gx is negative 2. So I can see that g of x is gotten when I move f of x 4 units down, which is option B. Option B is the right answer. What if I was looking at a horizontal transformation? So let's understand that. So I already have this thing, the equations of fx and gx, and I'll clean the figure as well. Right. And now I'm looking at a horizontal transformation. I'm moving from minus 1, 0 to 1, 0. Right? So I'm shifting fx 2 units to the right, which means that g of x should be f of x minus 2, right? Because if I'm shifting fx 2 units to the right, then the new function would be f of x minus 2. So what is f of x? F of x is 2x plus 2 So g of x should be 2 of x minus 2 plus 2, which is 2x minus 4 plus 2, which is 2x minus 2. So I get the same result when I apply a horizontal transformation. So this is the concept, right? Here, the options were representing vertical transformation. So B was the right answer. But if the options had represented a horizontal transformation, then this would be the correct answer. Okay, hope this was useful. If it was, hit like and subscribe to the channel. Let me know if there are any other math videos in this series, Basics Explained, where I discuss fundamentals. Let me know if you need any other math videos, and I'll try and upload those. I'll see you guys soon in a new video. Take care. Bye-bye.